So another lecture on vectors. We are solving few remaining problems from exercise 5.1. So in this question we have here 5.1, question number 5, very basic question it is. Check whether the vectors 2i cap plus 2j cap plus 3k cap. The another vector is minus 3i cap plus 3j cap plus 2k cap. And the third vector is 3i cap plus 4k cap form a triangle or not. We have to check whether these three vectors they form a triangle or they don't. So what I will do is I'll consider these vectors as a bar, b bar and c bar. Okay, so I write here let a bar equals to first vector 2i cap plus 2j cap plus 3k cap, b bar equal to minus 3i cap plus 3j cap plus 2k cap, and c bar is 3i cap plus 4k cap. Now what you need to follow here is, see, if I have a if three vectors are like this, if three vectors are like this, suppose I have three vectors as a bar, b bar and c bar. See, I do not know which vector is where, but then it is just for the sake of making you understand. Suppose I have three vectors like this, a bar, b bar and c bar. So if I add here, see, if I add here vector a bar and b bar, a bar plus b bar, okay, I get the third vector c bar. I see here a bar is this vector plus b bar. So from here to here, then here to here is finally here. You understand? So a bar plus b bar is same as c bar. So here I wrote this way, but for that matter, it could be sum of any two vectors. So it could be sum of any two vectors. For that matter, see, if this wasn't a bar this way, if it was some other vector, you understand? Not necessarily this way. See, if it was here, I had b bar, c bar and a bar. So then in that case, what we would have written? We would have written b bar plus c bar is equal to a bar. So if I get even, if I get even this way, b bar, if I get even b bar plus c bar, if I get b bar plus c bar is equal to a bar, then also it is okay. Still, the triangle law of vector addition is working. Okay, the triangle law of vector addition holds true. In that case, I can say that these three vectors form a triangle. I can say that these three vectors form a triangle. Okay. So we are given three vectors and we have to show that, in fact, we have to check. We don't have to show it. We have to check. We have to check whether these three vectors form a triangle. Now, we all know that in a triangle, the triangle law of vector addition will definitely hold true. The triangle law of vector addition definitely will hold true. That is, if I add any two vectors, I should get the third vector. Okay. If I add any two vectors, I should get the third vector. So either I should get the third vector as it is, or I should get the negative of the third vector, because the chances are that the given three vectors are in this form. Okay. The chances are that given three vectors are in this form. They are in one direction. You understand? So if I add a bar plus b bar, and instead of getting c bar, if I get minus c bar, then also it is okay. Okay, because if c bar is this, if this is what is c bar, and I get minus c bar, it is still okay. So what is important, that if I if I am adding three vectors, I should get, I'm sorry, if I'm adding any two vectors, I should get either the third vector or I should get negative of third vector. That is what I'll have to do. So I repeat once again, I will add any two vectors, and if I get the third vector, I add any two vectors like here, and I get the third vector. Then I say that these three vectors form a triangle. And in case if I get the negative of third vector, then also I would say that it forms a vector. It forms a triangle. The three vectors form a triangle. So let us begin with this. Let me start with a bar plus b bar. See, I will add a bar plus b bar. So when I add a bar plus b bar, see what do I get? I get here minus I cap plus 5j cap plus 5k cap. So is this vector by any chance equal to c bar or negative of c bar? No. Okay, no. So then I will go for b bar plus c bar. Okay, I'll have to go for all combination. So here I get 0 I cap plus 3j cap plus 6k cap. So is this vector by any chance a bar, negative a bar or a bar? No. So now I go for final, that is I will go for a bar plus c bar. So when I go for a bar plus c bar, I get 5 I cap plus 2j cap plus 7k cap. Is this vector by any chance equal to b bar or negative of b bar? The answer is no. So in this, now what you will say? You will say therefore the given three vectors, the given three vectors do not form a triangle. They do not form a triangle. I hope it's clear to you. Very fundamental problem, but quite good problem. So here we have question number 7 from exercise 5.1, which is again a very fundamental question, very basic question, but very essential for knowing. Find the distance from 4 minus 2, 6 to each of the following. So this is a point. 4 minus 2, 6 is a point in space. You have a point in space 4 minus 2, 6. This is x coordinate, y coordinate, and z coordinate. 4 minus 2, 6 is a point in space. We have to find the distance of this point from each of the following. That is distance from xy plane. Distance of this from xy plane. Distance of this point from xy plane. Now remember, distance of a point from xy plane is its z coordinate. See, this is xy plane. For your reference, I have drawn a diagram here, and in this diagram, I have taken the point as P. So this point, what is its distance from xy plane? So you can check that this is the distance from xy plane. This, the pink arrow, okay? XY plane is this plane. This is XY plane. This is XY plane. I hope you understand. This is XY plane. This is XY. So this distance is, the distance from XY plane is the Z coordinate. Distance from XY plane is Z coordinate. Distance of a point from XY plane is its Z coordinate. Okay. So what's the answer? Therefore, 6 is the distance. 6 is the distance. Then you have distance from YZ plane. Distance of a point from YZ plane will be its x coordinate. So 4 is the distance. 4 is the distance. 4 units is the distance. Distance from XZ plane. Where is XZ plane? See, this plane is XZ plane. This plane here is XZ plane. You can check. See this? This is XZ plane. the vertical, this is xz plane. This is xz plane. Distance from xz plane will be the y coordinate. Which distance? It is this distance, which is distance from xz plane. See this distance. This is the distance from xz plane, which is y coordinate. Distance from xz plane is y coordinate. So y coordinate is 4, sorry, -2. But you know, distance cannot be negative. So 2 is the distance. Distance cannot be negative. Distance is always positive. So you have a negative. If you have a negative number, you ignore that negative sign. Okay, so the distance is 2. Now we have distance from x-axis, y-axis, and z-axis. Okay, let me get the distance from y-axis. Okay, so look at this cuboid. This point P is in the space, and in order to reach this point P, what I need to do, see, this is origin. From origin, I moved x units in the direction of x-axis. Then from there, I moved y units in the direction of y-axis. Then I move z in the direction of z-axis. Okay. So this is the displacement in order to reach point P. The displacement in the x direction is x, then y, and then z. See, that's why the coordinates are x, y, z. I have to find the distance from x-axis, y-axis, and z-axis. So in order to make you understand this, I shall first find the distance from y-axis. Let me find distance from y-axis. So for that, what I do, I draw a perpendicular from point P on y-axis. I draw a perpendicular from point P on y-axis. Remember this perpendicular, I name it as PB. Okay, let me name this as PB. And this perpendicular, it lies in one of the surface of cuboid. So if this point is P, if this is N, and this is say Q. So the surface P and BQ. Okay, so this PB lies in P and BQ. That you need to understand. Where does PB lie? PB lie in this surface P and BQ. It lies in this surface P and BQ. Now what I do is, as I know that this is perpendicular, see, I know that this angle is 90 degree, angle with the y-axis. PB is perpendicular to y-axis. You can check PB is perpendicular to y-axis. PB is perpendicular to y-axis. I want PB. What do I do? See. Refer to the triangle PNB. So I write here in triangle PNB. Now you can check. The triangle PNB is a right angle triangle because this is also 90 degree. You see this? This triangle is also right angle at N. How big is PN? PN is Z. And how big is NB? NB is same as OA. NB is same as OA. NB and OA, they are equal. So NB is X. Now I will apply the Pythagoras theorem in triangle PNB. So see, I get here I get here Pn square plus NB square equals to PB square, which is the hypotenuse. So I get Z square, Pn square is Z square. I get here Z square plus X square equals to PB square. So what is PB equal to? PB equal to square root of X square plus Z square. I hope it is clear now. So distance from y-axis is square root of X square plus Z square. Okay. What will be distance from z-axis? Distance from z-axis, for that, remember, you will have to draw a perpendicular. You will have to draw a perpendicular from point P to z-axis. See, you will have to draw this. You will have to draw a perpendicular like this. This way. And where will it lie? It will lie in the upper surface of cuboid. If I name this as C and here R, then where will it lie? It will lie in this surface. It will lie in this surface. The upper surface. And it is the perpendicular. It's the perpendicular. See. You need to find CP. So how will you find CP? CP is, see, you have here, you can take any of the triangle. You can take the triangle PCR or PCQ, whichever triangle you want. So see, PCR is again right angle. How big is CR? It is X. How big is PR? It is Y. So how big will be CP? It is square root of X square plus Y square. Distance from Z axis is square root of X square plus Y square. So what is distance from X axis? It is square root of Y square plus Z square. Distance from x-axis is square root of y square plus z square. Here, square root of x square plus z square. And here, square root of x square plus y square. Okay, so I shall now calculate this. Distance from x-axis will be, I hope you followed this. So here, distance from x-axis will be square root of y square plus z square. So minus 2 square is 4 plus 6 square, 36. It is square root of 40. Then distance from y-axis is square root of x square plus z square. So 16 plus 36. 16 plus 36, that is equal to square root of 52. And then you have square root of x square plus y square. That is 16 plus 4, which is equal to square root of 20. I hope you all have followed it. In this question, we are not asked the distance of point from the origin. The question is not giving you, the question is not asking you the distance of the point from the origin. But in case if you have to find distance from the origin, you should understand that what is distance from origin. The distance from origin is this. So this is distance from the origin. What is it? It is nothing but the magnitude of OP bar. So distance of point P from origin is magnitude of OP bar. It is magnitude of OP bar. What is OP bar? If you know the coordinates of point P, then OP bar is xi cap plus yj cap plus zk cap plus zk cap. This is OP bar. So what is mod of OP bar? Mod of OP bar is square root of x square plus y square plus z square. So distance from the origin What will be distance of this point from origin? It will be square root of 4 square. Square root of 4 square, that is 16 plus 4 plus 36. That is square root of 56. This is distance from origin. They haven't asked you, but I taught you in case if such a question be there, you can solve it like this. So now from exercise 5.1, question number 8 is very simple. This you will do on your own. And question number 9. Question number 9 is find the area of the triangle with vertices 1, 1, 0, 0, 1, 0, 1 and 0, 1, 1. This problem we shall be taking after doing the vector product of two vectors. Okay, when I will have taught you the cross product, then I will teach you how to solve this problem. So for now, we are not solving this question number 9. We will do this only after completion of vector product of two vectors. So this problem you will understand when you will have studied vector product of two vectors. Okay. Now those students who have studied vector product of two vectors, for them, let me now teach this. How is this solved? In case if you haven't done vector product of two vectors, then you will have to first see that video, you will have to learn that and then solve. So here we have a triangle. I'm solving for those students who have done vector product of two vectors. So here we have a triangle and the vertices of the triangle are 1, 1, 0, 1, 0, 1, 0, 1, 1. I assume these three vertices to be ABC. What I will do is I shall find out AB bar and BC bar. I will find out AB bar and AC bar. Okay, I will find out these two adjacent vectors originating from point A. What I shall find? I will find out AB bar and AC bar. So for this, what will be, first of all, let me write the position vector of these points. So A bar, B bar and C bar will be, A bar will be I cap plus J cap plus 0 K cap. B bar will be I cap plus 0 J cap plus K cap and C bar will be 0 I cap plus J cap plus K cap. So now I shall find out AB bar. AB bar is B bar minus A bar. So B bar minus A bar will be, B bar minus A bar will be K cap minus J cap. I got AB bar. Then I will find out, as I said, I'll find out AC bar. AC bar will be C bar minus A bar. C bar minus A bar. C bar minus A bar. So it will be C bar minus A bar. So J cap plus K cap minus of I cap minus J cap. So you have here minus I cap plus K cap. This is what you have as AC bar. Okay. After finding AB bar and AC bar, it is time now I use the formula for area of a triangle. See, area of this triangle ABC, area triangle ABC, area triangle ABC will be equal to 1 upon 2 into mod of AB bar cross AC bar. 1 upon 2 into mod of AB bar cross AC bar. 1 upon 2 into mod of AB bar cross AC bar. So first of all, I will have to find out AB bar cross AC bar. So AB bar cross AC bar will be, cross AC bar will be determinant I cap, J cap, K cap, AB bar 0, 0, -1, 1. Remember, AB bar is AB bar, if you need to write in proper order. So that will be minus J cap plus K cap. Okay, so -1. You understand here? See, here I've written K cap first and J later, but it should actually be minus J cap plus K cap. So you write -1 plus 1. And what is AC bar? AC bar is -1, 0, and 1. Now you calculate. So here you have, so what do you get? You get this as I cap into -1 minus 0 minus J cap into 0 plus 1 plus K cap into 0 minus 1. So I get here minus I cap minus J cap minus K cap. This is AB bar cross AC bar. What do I do next? I find out the magnitude of this. So here I have now AB bar cross AC bar magnitude. I find out the magnitude of AB bar cross AC bar. And what is it equal to? Magnitude of AB bar cross AC bar A. See, this is AB bar cross AC bar. So magnitude of this will be square root of -1 square plus -1 square plus -1 square. Okay. That is equal to square root of 3. So what is finally area of triangle ABC? Therefore, area triangle ABC is equal to 1 upon 2 into mod of this, that is root 3. That is root 3 by 2 square units. Square units. Okay, this we have done.